all cybersecurity types of stuff like that. So this is going to be the last week where we're just kind of touching around, doing a little sample of different technologies, getting a good foundation. Just like with Windows and Linux, the intent this week isn't necessarily to be, a full-blown expert on um, cloud computing. And then on top of that, cloud computing is so vast. Like there's, in this lab, we're going to touch in on some Azure, talk a little bit about AWS, but there's so much different solutions out there between Oracle and tons of other, smaller companies that are cloud providers. So, yeah, so we'll get started. You can go to the next slide. The definitions of cloud computing. So, essentially, cloud computing is there's all these jokes out there about this is cloud computing is basically somebody else's computer. So in the early days, and it's still on to this day, companies still leverage data centers. It'll be buildings that house hundreds or thousands of servers, and originally it started off where one company owns that physical footprint. They got to go and either rent or purchase an entire physical footprint to place all these servers in their data center. Then it kind of evolved to shared data centers because everyone's trying to reduce the cost. If you're going to have a data center, not only do you have to buy all the hardware for it, pay the bill, electric bills, all the other utility bills, purchase that physical internet connection, paying for the property, rent, real estate, whatever it is. There's a lot of compounding costs when you're putting servers in a data center. So, and everyone's trying to continue to do some cost savings. So, it kind of evolved into shared data centers where, you'd instead of buying a whole data center, people would lease out X amount of servers in a physical data center. And, it's gotten to the point where it's evolved all the way to where you're just paying for cloud computing. I don't, for example, every company I work for has had some sort of cloud footprint, whether it's Amazon Web Services or Azure. You don't necessarily even know where that computer is. You're not so concerned about where is the data center. Sometimes you can select the region you might want to focus. US West is a very popular region where you can ask Amazon when you sign up for Amazon Web Services, you put your you sign up saying I want services out of US West. So it's all invisible to you in the back end. You just have a cloud account and you put resources up in the cloud, and you don't even necessarily touch the actual computers. You don't have to worry about what switches are connecting my cloud computing devices. What backup power supplies do I need to worry about? Do I, need to worry about voltage? How many outlets does my circuit breaker support? All this stuff. And then, good example today, power outages. You don't have to necessarily factor all that in with cloud computing. So, that's essentially a definition of cloud computing. Go to the next slide. So benefits. I kind of touched on some of this already. The big thing that I talk about, cost efficiency. Most times it is more cost effective to put things in the cloud. In the cloud, you're typically paying for how many computing cycles you use. You might pay for how long it's been up, or how much CPU usage you have, or how much data, or how much bandwidth. Those are the typical cost models you'll see varying between what your what your cloud service providers offer. So depending on what you're using, that's typically the model. I would say sometimes it's not always the case. It might still be you could still be more cost efficient to host things on site. It's one of those things you got to take a look at what's the cost model, and what is your usage leverage for that cost model. Scalability, that's important in the cloud. So a lot of times when I'm configuring my cloud servers, when I set my server up, it's going to ask me how much CPUs, how much RAM, how much hard disk space, and then a lot of times you can change that relatively quickly. So maybe I first set up a server and I want 4 CPU cores, 16 gigs of RAM, and 500 gigs of hard drive. It's just basic setup, and then later on my application grows and I want to increase that. Sometimes it's as simple as going into the web GUI and just clicking plus plus, extra CPU, extra RAM, quick little config change, and then it scales up so quickly. And then if I wanted to stand up another thing, another host in my cloud, it's pretty simple. I don't have to worry too much about physically moving things in, purchasing, and then it's quite just as easy as scaling it back. If I no longer require that service, I just go into my configuration console, say, delete this server or reduce the resources, and then my cost goes down. I don't have to worry about physically, unracking servers from a data center, trying to sell or recycle that hardware. You let the cloud service provider worry about all of that in the back end. Is completely invisible to you. Accessibility. So, I can access this cloud console just about anywhere. And I would say, I'm speaking about like the bigger ones, Amazon Web Services, Microsoft Azure. They're all accessible all over the world, pending any kind of, geopolitical restrictions or anything like that. But from a technical perspective, anywhere you have internet connection, you should be able to access your cloud resources. And reliability. So, they're not subject to the physical infrastructure problems that you're going to run into in a data center. For example, today, if you're in Washington, lots of power outages. Maybe your data center doesn't have a power outage, but a power or pole line within the network path goes down, and now you have now your data center doesn't have internet connection, something of that nature. All that stuff you typically don't worry about. It's in the cloud in multiple data centers spread across multiple infrastructures, so that there is no single point of failure. They basically have high availability, high redundancy to kind of increase that reliability. I think if you were to Google AWS availability percentages, they'd be in the 99 point multiple nines. It's physically impossible for anyone to be at 100%, but they'll be about as far as you can get to it. Next slide, please. Right, so there's different models. So public cloud, this is the most basic setup when you go and get a cloud services. You go on AWS, you get a virtual server, and it's exposed to the internet. Of course, you can configure that server to be locked down, kind of like how we talked about modifying the firewall, accepting only traffic that you think. But generally speaking, that basic setup in AWS, Microsoft Azure is going to be the public cloud model. If you're a much larger organization and you can afford to, it's going to cost more money if you want to have a private cloud, and it's essentially you're logically segmented from the internet, and it's like you have your own private data center without having to worry about the physical infrastructure costs of having that private data center. Examples of this, if you were to look up GovCloud, the Department of Defense, for the longest time, they never entertained the idea of putting anything in the cloud. But as they started seeing private cloud infrastructure get much more secure, much more highly maintained. We do have FedRAMP, which is the GovCloud that we see out there, and that's a big example of private cloud. Most big companies do have some sort of private cloud footprint. Here at GoDaddy, we have private cloud and we have public cloud. So depending on when my team is trying to stand up a server, depending on what we're trying to do, is this something that is an internal tool? We're going to put it up in our private cloud infrastructure. If it's something that customers need to access, it's going to be in our public cloud. And of course, hybrid cloud. It's a combination. I would say anyone that's likely doing customer-facing type of work, you're going to have that public-private cloud if they're a big company. Smaller companies, it'll just be all public. And that's kind of the model. Like anytime you're trying to make something more private, specific to your organization, you're spending more money, more resources. So I would say hybrid cloud. There's another term that people will say, and it means something completely different. And that other terminology that you'll hear what hybrid cloud is going to be, if they have Amazon and Microsoft Azure or multiple different cloud providers. So even though this is the original meaning of hybrid cloud, I've definitely heard people reference hybrid cloud when they're talking about having multiple cloud services providers. And in my own personal note on that, um, you know, you're always operating at the needs of the business. You know, from a security perspective, it's best to have one cloud service provider and force everything through a secure configuration pipeline through that one cloud service provider and reduce that attack surface. You know, there's that term again, we're always trying to reduce our attack surface. So, you know, if security has enough pull, try to do that. Try to keep things through one cloud service provider. It's not always the case. You know, sometimes the needs of the business, you're going to have to operate with the products that you know, make money. So, good example. You know, I was at T-Mobile. You know, we already had AWS, we already had Microsoft Azure, and then you know, T-Mobile started partnering with YouTube TV. So, you know, they had that promo they put out where if you're a YouTube TV customer, you get X amount of discount from T-Mobile. What that meant in the back end is we started standing up YouTube TV proxy servers within the T-Mobile network, so that way customers get that high speed streaming. So next thing you know, due to a business need, we went from having Amazon Cloud, Microsoft Cloud, and adding in Google Cloud. So now we're you know, that attack surface is getting much larger. So just some things to kind of keep in mind about hybrid cloud and which service provider is best. I don't think anyone's best. I think it's you got to meet the business needs, and then on top of that, you know, you've got to build that secure pipeline for regardless of what cloud service provider you're using. We'll probably talk way more about some security stuff there, but we'll come to the next slide. So right here's what I was talking about, graphical depiction that kind of puts it in perspective. You know, we have our public cloud on the left, which you know, all the things we mentioned, the private cloud on the right, and you know, it's talking about it says connect via company intranet. I don't think that's a term we really talked about early on in the class that came up, but the term intranet is usually referring to the public internet. You don't see this term intranet being used too much anymore, but intranet is typically used to refer to a network within an organization. It's not the internet. It could connect to the internet, but it's that corporate intranet. So that's the term you're seeing there. So you're saying that private cloud is connecting to the intranet. It's operating in that space. I don't think I've seen the terminology in our courseware, but there's another term that people that is not quite used anymore because we have cloud computing, but it used to be extranet, is where you're taking two different intranets and you're connecting them to each other. But nowadays, everything is kind of operating within the hybrid cloud space. We can go to the next slide. Hey, Jewel, you can go to the next slide. All right. I'll probably add in a bit of a graphical aid to help with this. But different kind of cloud service models exist. In fact, can you quickly go to the next slide? I want to see if this is on there as well, if they have a better depiction here. Yeah, here we go. Yeah, we can stay on this slide here. All right, so so there's different cloud computing service models. So infrastructure as a service. This is essentially, we're talking about you know, majority Amazon Web Services. This is where it's providing you like a virtual server or a virtual storage. It's essentially supplementing, like if you were to have a physical data center computer, you're paying for infrastructure as a service, as opposed to as you can see, you get higher um, platforms as a service. This is you can think of some examples here, like Windows Active Directory, something that's really popular. Most companies use. So in week 3, we did our Windows lab where we built Microsoft Active Directory. Instead of doing that, building Active Directory in your data center, you can actually purchase Azure Active Directory, and it's in the cloud. You can configure users just like you would if you had Active Directory within your data center, but instead you're paying for that platform as a service. So right there is kind of a definition of the difference there. So you're not managing Windows Server. So if you were managing Windows Server, so like in those labs we did the server configurations, that's infrastructure. And then when in those other labs where we start tinkering around within Active Directory users and contributors, that would be a platform. And then it's kind of almost like layering up. So the bottom layer is infrastructure, and we have a platform running on top of that. And then on top of that, at the very top is software as a service. Right now we're using Teams. You might be using Outlook 365 or Microsoft 365. That's an example is software as a service. So this is email, business processes, those types of applications. So depending on what model, it's important to understand, is this IaaS, infrastructure as a service, is it PaaS, platform as a service, or is it SaaS, software as a service? I'm not a fan of a million acronyms out there, but it's important to understand these ones, what they're referring to, and being able to map it as what am I paying for? Am I paying for PaaS, SaaS, infrastructure? Being an understanding. Next slide, please. So this is just a very, very generic depiction of cloud computing. Whether you're at home, like on the left right here, you're connected to that, your home router, which is connected to your internet service provider. Whether you're at the corporate internet at a building, you're connected to the switch on the wall. I always kind of tell people when we're working on cloud, I'm like, I treat it as a big blob on the internet. I don't know what's happening within the cloud infrastructure. I don't know which routers, switches, Amazon Web Services running between my home router or my corporate switch to get to my server in the cloud. I just treat it's all one big cloud blob, and unless you're working on the other end, unless you're going to be working for Amazon or Microsoft or another cloud provider, from this end of the perspective as a customer, from a infrastructure as a service, platform as a service, software as a service, that's all part of what you're paying for. You don't need to worry about configuring that. If something goes down, they have a service level agreement. You let them know, hey, it's down, and they fix it. So that's and we'll talk a little bit more about some of that in a few slides here. Next slide, please. We'll go to the next one, importance of cloud security. All right, so one more up or importance of cloud security. I might be lagging here on mine. All right, so just like anything, people always ask, what's more safe? Is it having your stuff in a data center behind a firewall, having it in the cloud? And you'll always have people who defend one versus the other. Someone's going to say cloud's more secure, on-prem is more secure, on-premises is more secure. I've seen bad incidents happen, whether it was in a data center, lab, or in the cloud. It's all about having that secure framework or that secure intake process. So, for my example, is if you're standing up your cloud from the scratch, you want to build your framework. You want to build a security certification process for anything new that gets stood up in the cloud. And then if let's say you're purchasing a third-party product and they have servers in the cloud, you want to have a process for bringing in third-party external cloud assets into your organization. And this is the same thing that you should be doing if it's in a data center. Everything should have a certification process, because it kind of doesn't matter if it's in the cloud or if it's in a data center. It's security is important, and either way can lead to a breach. I've seen breaches go from it starts in the cloud and they were able to laterally move on-prem or the other or vice versa. So cloud security is just as important as any other digital landscape, as it says here. Next slide, please. This is an interesting one. So shared responsibility, I would say this is constantly changing. So there's always a limit to what the cloud service provider is going to do as far as security goes, what they're liable for, and what you as the customer is responsible for. So everyone's a little bit different. And here's an example. So let's say I'm a cloud customer. I run like a store. I'm selling homemade soap, something like that. So I want to set up some website and services and have employees. So I build all these things on AWS cloud. And then maybe it's I build my own Windows services, and then I give everyone a really bad password. I make everyone's account password 1234. Now, Amazon's not going to be responsible for what you are, configuring for your users. And so, in this example, they're going to be responsible for the infrastructure, making sure nobody can backdoor into your Windows server. They're going to make sure that they're probably going to have some, DOS denial service level of agreement where they're not going to let people DDoS or DOS your sites, but they're not going to be responsible for your user password security. They're not going to tell you all your administrator accounts have to have MFA. So this is where the shared responsibility. They're going to outline what they're responsible for, and they're going to tell you what you're responsible for. And there's a lot of legality behind this. As you can imagine, let's say you're selling your homemade soap. You have a breach, and then now your customers, their credit card information's been stolen. And this is where that, they're gonna protect themselves with this shared responsibility model and say, well, the breach was caused due to you guys having, password 123 as your password for all the users. And versus if you were to, if there was evidence to say that the attackers got in through a backdoor in Amazon, maybe an Amazon account got compromised and that's how they came in. So so they're going to be responsible for certain things, and you as a customer is going to be responsible for other things. And it's mainly there for legal protections, because depending on who it is at fault, that's who's responsible for the PCI disclosures, who's going to take on the responsibility of remediating all those stolen credit cards, all that type of thing. Oh yeah, so thanks, Joel. So right here, example, cloud service responsibilities. Infrastructure is a big one. Just like infrastructure as a service, you're going to see all this, or platform as a service. They're protecting that aspect of it. But yeah, most commonly, I see a lot of cases where people just have bad passwords and they can't stop you from logging in. They might help you and advise you on how to set things up securely, but they're not going to make you do that. So, and they'll be outlined in their responsibilities. Next slide, please. Yeah, so right here, a big one that I keep kind of talking around, identity access management. That's essentially, what's your passwords? What's who can log on? Is there MFA? And in configuration, do I want to let people connect from every port on the internet? That's solely up to me. I might have legitimate use cases where I want a server to communicate on certain ports. Maybe I want to have certain applications open. And with that responsibility you take on, that's your responsibility to make sure it's secure. How you store your data, as data security. Amazon's not going to tell you what to encrypt. All those things is going to be up to you as a customer. So again, and this would be the same thing if you're in a data center. All these things that are customer responsibilities, they're not new because you're in the cloud, but they're just more emphasized because they're not at all going to be something that your cloud service provider is going to do. I would say the bottom one, uh, and the bottom one, and a few other things here. There's a lot of cases where this is something you can also buy. So security monitoring, incident response. I'm not sure exactly with Amazon where they're at on this. It's been a while. I want to say they do have for extra cost. You can engage them to do some incident response if you have an incident as a AWS customer. Microsoft, they definitely have their own. It's called Dart detection and response team. Depending on what level of customer you are and how much you're agreeing to pay by the hour. These are all agreements you can put in place, and they'll have in place. So, and you'll see this in a lot of places where you can actually pay for additional services, and then it all depends. Do you insource or outsource the security team? Next slide, please. We kind of touched on some of these right here. So, cloud security challenges. Uh, you know, you're gonna if you have a breach, it's already difficult as it is, whether it's in your own data center in the cloud. But during that breach process, you're gonna hopefully have some kind of legal privacy counsel, because this is where there's going to be fingers pointing in both directions on to who's liable, who's at fault. So that's always a challenge. Anytime you have a shared responsibility, you're going to have that. Lawyers are going to get involved, and they're going to really figure out who's quote unquote responsible for the breach. So that's always good to have everything documented. Make sure you have a process in place. Insider threat, I think that's just like anything. It's if you have individuals that have access to things, there's always a level of insider risk, whether you're outsourcing your support to regions that are easier to coerce or bribe. It's always going to be an issue, or if you have a disgruntled employee that just may want to do some damage on the way out. That's something that's a consideration no matter whether you have cloud or not. Data loss, I would say this is one area where public cloud makes this a bit more riskier. A lot of times you hear breaches where bad actor gets access to what's called the S3 bucket. Basically, if you're an Amazon cloud customer, S3 stands for their storage service. It's S3 stands for, it's like storage, secure storage service. I want to say that. So 3S is S3. That's their service. And a lot of times by default, they'll let you create a storage service within the public cloud and not have any access control. You can Google on the internet. There's tons of data losses where people have just put up a public storage and left it unsecure, and bad actors, security researchers, they're actually scanning every day AWS looking for unsecure storage buckets, and there's treasure troves of data always found on a regular basis. So I think data loss is something that's more emphasized with public cloud as well. DDoS. So this is um, this is one where it could be something that is covered by the cloud service provider. I would say that Amazon will protect from certain types of DDoS attacks, just like regular internet DDoS attacks, without paying extra. And a lot of times, if they're specifically targeting your endpoint, this is where you might have to pay a little extra for a higher level of DDoS attack prevention. They call it, I want to say the product is called AWS Shield, and that usually costs a little extra, and it gives you a bit more of dynamic protection. Again, it's how big you are. So if you're a small company, unless it's very rare that you're going to become the target of a targeted denial of service attack. So typically this isn't something you're going to worry about unless you are working for a large organization to where you can afford services like that. And I quote a lot of these AWS services, and that's not to say that other providers like Microsoft Azure does not have a very similar product. I'm just most familiar with them. So you might hear me say AWS Shield, S3. A lot of these things, there's the same service for Azure, and most of the labs that we're going to do this week are Azure, and I'm way more familiar with the AWS side of things. So it will be a little bit of first time or very very long ago for sure that I'll be doing some of these labs where I've only ever done Azure in a lab and not necessarily where I've worked with AWS for many years. Next slide, please. Cloud security best practices. Like I've been saying, a lot of the things you see here about cloud security, they apply to everything. The only difference is that if you're in a data center, you're more obscure. You're not going to be out there on the public internet as widely available and accessible. They might only like your IP might only be exposed if through the data center IP you have. Out on the cloud, all these things are going to be, they're out in the open. If you don't secure them, they will get authenticated. So strong authentication, at the very least, complex password. We go back to week 1. We don't reuse any passwords. We have a rotation to where we're gonna need to change it on a regular basis, and if at all possible, multi-factor. And examples of what's going to happen if you have like your cloud administrator account and that cloud administrator account gets compromised. At the very worst, there's a lot of sensitive data you could lose, but at the very minimum, there's these automated bots that are controlled by botnets or hackers, and you'll see all of a sudden they'll start spinning up new servers on your account, and those new servers are going to run crypto miners. They're going to max up that CPU usage, and within a matter of an hour, you might have 100 crypto miners running under your account, and then you get a notice from AWS that you've already maxed out your monthly bill of whatever it's set to. So it can be very costly to have those types of accounts compromised. Regular audits. This goes kind of talking about like things like password age. Do these administrators still live in your organization? Kind of like we talked about the root account the other day. You should have that one God Amazon or cloud service provider account, and treat that like a break glass. Put that password in a password manager. Don't issue it out, and then issue out slightly lower, again, least privilege accounts to people that need it, and audit those accounts. So there's that same security strategy where you don't have that admin that has rights to everything just being openly used. That goes for everything. So it goes right here in the cloud. Backup and recovery. We talked about the Active Directory backup. There still should be backup. A lot of times this may be something that you can pay for, or it might be part of your cloud service agreement. But do make sure that you are understanding what's available for your cloud backups and what's your plan to recover. And then also keep in mind, not only from legitimate non-malicious ways of losing data, but let's say that administrator account gets compromised. Does that administrator account have the ability to corrupt your backups? If it's ransomware, does that, is it going to be safe from ransomware? So make sure those are implemented into your plan. Security awareness. I would say any user that has cloud privileges, they can stand up services within a cloud. That should be included in their security awareness training. We talked about phishing awareness, password awareness. There should be some specific understanding for people who are creating cloud resources. Like I mentioned, public S3 buckets where people are just creating storage buckets and not putting any kind of password protection. That should be something where you're educating your employees on how do you create things in the cloud and how do you secure them. Next slide, please. My conclusion on this is, the cloud will get you. It's cost savings. For example, I've been with GoDaddy for a couple years. They've maybe for the past decade, they've said they want to get out of the business of running data centers and into the business of just delivering products to customers. So taking out data centers and moving to the cloud. That's their goal. So, and that's what you see a lot of people doing. Not, nobody. You don't need to have a data center. You don't need to have a server. You can just you run a place to do your business, and you put everything in the cloud, and you don't have to worry about that. So cloud is going to continue to mature and be in use. And it's not like you should be doing anything different for cloud security. You should always be doing these cloud security best practices, regardless of whether it's in the cloud. It's just that, by design, some of these things are more vulnerable, more susceptible to living in the public cloud. So you always got to keep that in mind, how easy it is. It's so easy for somebody to create public storage or put a server on open to the internet, and all of a sudden they're just testing their building. They have an administrator account, weak password. They get sidetracked with some other work, forget that server's there, and next thing you know, you have this weakly configured server just sitting on the internet, and it gets taken over. These having those frameworks, having those audits, those are all going to prevent those problems, because the human aspect is always going to be what originates a lot of problems. That's all for what we're going over today. Hopefully, we won't have this internet issue next week. I'll go over the labs. I dropped in chat. I'll put it in right now. What the labs are for this for today. They're actually hopefully relatively easy. We're just going to create an Amazon Web Service account and create what's called a resource group for it. So I drop it in the chat here. So the lab 5.1 and 5.2. We'll go over that on Thursday, and that's what we'll be working on before Thursday. Yeah, just an intro to Azure. Again, we're not trying to become Azure experts. Like I said, I'm probably gonna, I don't think I've stood up an Azure account since I did it for a lab on my own. I've never professionally administered anything in Azure. I'm more on the AWS side, but again, we're getting a good sample, a good framework on the different technologies that we could need to worry about as a cybersecurity practitioner. Any questions, concerns, or anything like that? All right. Well, thanks everyone. I'll be available for a bit. If you guys want to get started in the labs.
I'm sorry to interrupt you.
Yeah, no problem.
Sorry, can you hear me?
Yeah.
I have a question about the quiz 6. I did it, and when I tried to do that assignment, it says that I need to, if I'm not wrong, the instruction says that I need to access the link, then to do the quiz 6. Then after I finish, I need to take a screenshot from his scores and send it over. I don't see any option to send that, and even though I did finish the quiz 6, so when I click submit it gives me automatically 0 out of 0. I'm kind of confused a little bit here. if you can help me.
You know, if you're, I'll chat with you. It shouldn't be a problem. I'm not too concerned that everybody complete the quizzes. I can just make that modification. So I'll send you a DM, Mohammed, and I
Okay,
can go ahead and modify that
perfect.
on my end.
I appreciate that. Thanks so much.
Yeah, generally speaking, all the quizzes that we have here, I'm not trying to use them as a pass or fail because we're not covering every single thing that's covered in those quizzes. But they're just
Right.
good to like go over them, see how you feel about the course, the topics that are in there, and if any questions that come up, definitely bring them up. But I'll go ahead and I'm gonna take a look. And Basir, I think you sent a similar message to Joel. I'll be taking a look at that as well. I can just modify it on the back end. It's not a big deal. Yeah. So I'll do that. I'll do that while we're opening up for labs.
Awesome. That's great.
Any other questions, concerns? All right. Well, you guys are welcome to get started on the labs, and hopefully, yeah, hopefully all the internet issues are resolved by Thursday.
Yeah, sounds good. Thanks so much for having me here.
Thanks, everyone. Have a